I'm John Price with Digame Systems. This is my first video, and in it, I thought I'd introduce a technology that we at Digame are using a lot on projects. Digame is an IoT company that helps other companies develop products. And this video, as I mentioned, is an introductory video to MQTT, and there's a ton of great ones out on the web right now. But what I'd like to do is provide yet one more. But this introductory video is going to be from the perspective of a guy who does a lot of Ruby programming. And so I'm going to take advantage of the Eclipse Foundation's Paho project and their Ruby API to develop a little distributed application that uses MQTT and connect it up via two brokers. One of them is the Eclipse Foundation Mosquitto broker, which I'll talk some more about in a bit. The other is Amazon's AWS IoT Core service. And let's see if we can get these fit into one video. If not, I'll split it into two parts. But let's continue. I mentioned my company, Digame Systems. We're a small software consulting house. We do custom development and contract R&D, and we really focus a lot on wireless technology. And we help companies develop IoT products. And so we do a lot of work in the RFID space, as well as NFC and other distributed applications like vehicle tracking. And our sweet spot, as I mentioned here on the slide, is that we really like to work kind of between the low-level hardware and firmware and upper-level enterprise type applications. And so a lot of what we do is connectivity, connecting up components. And that's really what MQTT is all about, is it's connecting up devices via a machine-to-machine protocol. So at a high level, what is this thing? And so it used to stand for message queuing telemetry transport, but we've since sort of dropped the explanation for the acronym. Is now just known as MQTT. And it is a publish subscribe model for devices to talk to each other. And what that means is you have a bunch of entities that are in communication, but they're in communication via the action of a broker that sits in the middle. So if you think about different kinds of topologies for network communication, this one is a hub and spoke model where components communicate with the central broker who then routes messages around. And clients can subscribe to information that they care about and publish information that they know how to talk about. And that's how this all fits together. It's an interesting protocol. It's built on top of TCP/IP, so it's got all the robustness associated with that and the security associated with the various TCP implementations like SSH and TLS. But it's also been designed for low bandwidth. The reason that is that it came out of the oil and gas industry back in '99. It was created by two guys, Andy Stanford Clark and Arlen Nipper, who worked together from different perspectives. Arlen's an embedded guy, and Andy is an IBM kind of distributed systems guy, and they got together to come up with something that would solve some big problems they were having in moving information around over low bandwidth and very expensive networks that were things like satellite uplink. And so they really cared a lot about A, reliability, and B, keeping the bandwidth down because they were being charged by the byte. Since then, it's become a standard in a couple of places. Oasis and Eclipse have both adopted standards around MQTT, and it's become incredibly popular since then. And so it's been very successful. You might say, well, '99 is quite a while ago. Jeff Bezos says all overnight success takes about 10 years. So this may not be exactly an overnight success, but it's incredibly successful. It's everywhere. It's in AWS IoT Core. It's in Google Cloud. It's in Microsoft's offering. Even Adafruit and a bunch of other companies that do embedded device support have put MQTT hooks in for things like microprocessors. It kind of got its start down here, not its start exactly, but it really took off after Facebook Messenger employed it for routing messages in its application. It scales well. I mentioned the Eclipse and Oasis. The Eclipse Foundation has a project called the Paho project. It is designed around developing MQTT interfaces from different software languages, so different programming languages like C#, Java, JavaScript, Python, and even Ruby, which is what I'll be talking about today. MQTT is finding its way into lots of things. It is bundled with Debian and actually is available on recent Raspberry Pi distributions. So you can just use it out of the box when you fire up a Raspberry Pi to build your applications there. How does it actually come together? How do you use this thing? Well, in principle, it works like this. You've got some sensors hanging off of your network, and you have a central broker, as I mentioned before, and then you have a number of interested parties who are wanting the information that's coming in off of that sensor network. And so these guys can do things like subscribe to different topics. And these two fellows up here on the top right, they're subscribing to any kind of temperature data that's going to come in off of that network. And the fellow down below, he only cares about data coming in off of temperature sensor 2. So if you look above, there's this hashtag in the kind of URL looking structure there. This gives you the option for wildcards, and so you can have, you can basically build subscription lists that let you kind of get pretty granular on what it is you're interested in. So when a sensor comes along and publishes this information, he says, "Hi, I'm temperature sensor 1, and here's my value." The broker, because he sees this subscription from the top two on the right as caring about anything, will route that information to them. But he won't send anything to the guy on the lower right because he only cares about stuff from sensor 2. In contrast, when sensor 2 sends out a message, the broker realizes that those subscriptions overlap, and so he fans out that data to everybody. Now, this is kind of a nice layout for a couple reasons. One in particular has to do with security, and that is the sensors don't know anything about the clients, and they don't accept connections from the outside world. They just make a connection to the broker, and so from that perspective, it is a kind of inherently more secure protocol than some others. The other thing is, as I mentioned before, it rides on top of TCP/IP, so we have all the benefits of the different security mechanisms that they have there. So it's just seen a ton of use. And so today I'm going to talk about Ruby, as I mentioned, and so I'm going to use the Paho Eclipse project, Paho's Ruby gem, and use it to talk to two brokers, one of which is the Eclipse Mosquitto broker, which is an incredibly popular broker that's bundled with the Raspberry Pi and Debian now. It is supported by Windows and Mac and Linux, and also a variety of other OSs. I'd also like to connect up to the AWS IoT Core. It's a little bit more sophisticated there, and you have some security that you're going to have to take care of, and so I thought that might be a nice augment. So what we're going to do is we're going to build a little distributed application. We're going to first put it in on infrastructure where we have a Mosquitto broker in the center, and then we're going to go move that over to Amazon's IoT Core. So I mentioned kind of the rough structure of MQTT, and you could see that you have publication and subscription. Thing to keep in mind is there's a whole bunch of events that take place when you start to do a set of transactions with that broker. So you first of all connect to the broker. You can publish information to the broker. You can subscribe to information from the broker. And all of these particular events, if you will, have been wrapped up in a number of APIs under the Paho project, where they use the unique features of different languages to present it in different ways. And so in this little example here, I'm showing how Paho presents the pub/rec or publication received event under Ruby. And so in the Ruby world, we would see this as an on message callback, and we can hang off of that callback any code we want to run whenever a new message shows up. And so in this particular case, we're just showing, hey, I got a message on this topic, and this is what the payload of that message was. And we can bump a counter, or we can do a bunch of other things with flags to sort of fit in with the rest of our application logic. I mentioned Paho a second ago. If you go out to their website, you can download their whole set or whole suite of APIs. They have things for pretty much everything. They've got C, C++, embedded C and C++, Java. They've got JavaScript, Python, Go, and I mentioned Ruby, which isn't even on this list because the list is getting kind of long. They also have different MQTT implementations for embedded systems that might be worth taking a look at if that's the kind of thing that you do in your work. The other piece I mentioned was the broker. And so in this diagram here, what we're going to do in our first little exercise of programming is we're going to be talking to Mosquitto broker. And Mosquitto is yet another Eclipse project. This is an open source Mosquitto broker, or open source MQTT broker. It runs on a wide variety of platforms. You can download it for free. And here we have it for Windows, Mac, Linux, as well as the Raspberry Pi, Ubuntu. A bunch of different implementations are available. And basically, in a Windows environment, you install it, you run it, and start it as a service, and it's just there available for your applications to talk to. So at this point, I think we can go ahead and look at how we want to talk to this thing from Ruby. So let's go over here and look at how we might want to publish a message to our broker. And so this is a Paho MQTT pub little application that I put together here. And what we're doing is we're creating a client based on their MQTT class. And as I mentioned, there are these callbacks. And one of the callbacks is I acknowledge that my message was acknowledged by the broker. So if I publish a message, the broker can tell me, "Yea, verily, I've received that, and I will treat it accordingly." The next phase in this is to say, okay, let's make that connection to the broker. And in our case, I'm running the Mosquitto on the same machine as this particular application is running on. So we're just connecting up to localhost. Mosquitto broker can support both secure and open connections. 1833 is a port you use for unencrypted data. So if you actually look at the TCP messages flying around, it's just clear text in this case. So let's build a message and fire it off. And so here's our topic. Our topic is test, and the message would be hello there. And so what we're doing is we tell the client to publish on this topic this message. And an option, there's a couple of options that are available on this publication. One of them is, hey, broker, do you hang on to that message in case somebody else comes along later and wants it? Or do you hang onto it until somebody asks for it? And then the second thing is, what kind of quality of service, what kind of guarantee do I have that my message makes it across to somebody who subscribes to it? So that's all this thing does. And so it wakes up, registers a callback, connects to the service, sends a little message, waits to see that its message was received, and then calls it good. So that's the whole application there. And if I go look at it running, we'll see something not too interesting, which will say, hey, message sent. So that's half of the link, right? We put together half the link in this particular case. So let's go look over here at how a subscriber for messages might use that information. And here we have a second little application, which is not much longer than the first one, which requires their gem. And build a new client. And in this case, we're registering two callbacks, one of them which is an on message callback, which means something's landed on the queue that I'm interested in. And I'll just display that message on the screen. And then we'll also register a callback to make sure that my subscription was properly received. And so I say, hey, I'm interested in a topic. This thing's going to fire when the broker says, got it, I understand what topic you're interested in. So in the same way we did with the publisher, the subscriber can say, I connect to the local host and subscribe to a topic. In this case, not publish to it, but subscribe to it, and wait for the subscription to be acknowledged, and then just sit and listen for stuff to come in. And in this case, I'm doing a while one, so he's just going to spin here, listening for messages forever, and he's never really going to hit this disconnect message. I just left it in as a placeholder. So let's take a look and see what happens when he runs. He's over here, and I'll pull up the publisher over here, and these two guys work together. So if I run the subscriber, he subscribed to a particular message, and now if I publish on a topic over here, bam. So he said, I'm sending this, and over here we received the test topic and with the message hello there. So we actually have a link between these two. And since this guy over here on the right is spinning, waiting for more messages, I can just rerun this, and it'll just see messages all day long. And so that's a very simple example of how you can put something like this together. Now that's just kind of not all that interesting. Let's see if we can make this more interesting by connecting it to some live data on the network. Okay, let's stop the listener here. All right. And I'll just clear this out and clear this guy out over here. Let's pop over here for a second. And I want to show you, whoops, doop, doop, doop. This is Open Weather, openweathermap.org. It is a service that has a nifty API for getting access to weather data. And weather data, has temperature information, so it seems kind of nice in the context of our current conversation. They have an API, and it's available at several levels. And they've got a free tier that lets you play around with it. And you can take a look at the API doc and get your own API key. And really, all you have to do in order to pull down weather information is execute a request, and back comes JSON data in a nice package for you. So you can then parse that any way you want, and it's actually pretty rich in terms of what it provides. And so there you go. So let's use that as our next tier of our little application. So one of the ways you can get information is by city in the Open Weather API. Let's kind of zoom in and see how they lay this out for us. So one of the simplest ways you can do it is you can just call their API with a particular version number and ask for the current weather in a particular city by name. And so they parse up the name for you and then come back with data that represents the state of that. And so they've got a pretty neat, rich, as I mentioned, JSON object that is returned here. You need an API key, and they provide you with one as part of the free tier. And I'll just use that in my application. Okay, we're back over in the publisher. We're building a little service that provides weather data, publishes weather data. And I've taken our publisher from before and just tweaked it a little bit to add extra functionality. So part of that process is to add two new things in our gems, our require statements here. net/HTTP, because we're dealing with an HTTP API, and JSON, because data coming back is a JSON object from the weather service. And I put in two new functions, two new utility functions. One is current weather for a city. So you pass in a city name, and it basically uses that as part of the URI for the API call into the weather service. So just like we were looking at earlier on the web page there, here's a call to their API, the version. Now we're passing in city as a variable that gets passed into the function, and my API key, which is big, hairy hexadecimal string. To make that happen, we're using the net HTTP class, which is just part of the net HTTP library or gem we're hooking in here. And because we're doing HTTPS, we have to use that URI scheme in our creation of the class. And so we instantiate the class, and we create the new URI request and execute it. Back will come the response. And what we're going to do is take the body of that response and parse it as a JSON object, and then we're going to return that object to the caller of the current weather function. There's one little utility function that I put in here just for convenience sake, and that is Kelvin to Fahrenheit. Their API that hands back the weather data returns everything in Kelvin. And I have a problem using Kelvin to figure out if I want to go outside or not. So just build a little utility function down here. So now let's go down and look through. Most of this code is identical to what we had before in our publisher, right? We've got the client being created. We register our callback for publishing. We make a connection to our local host. And now we've got the new section. New section is, hey, let's make a list of cities we're interested in. And so down here we have San Jose and Tucson, Phoenix, and Atlanta. Pick your own favorite city. And then for each of those cities, I just love Ruby in this regard. For each city, go grab the current weather. And it calls that function up above and pulls back a JSON object. And then what we do is we create the current temperature by executing the Kelvin to Fahrenheit function on that object, and we're asking for main subcategory temperature, which is just part of the JSON tree. And then what we do is we publish. And so for each one of these cities, we say we're waiting for an acknowledgement. We publish the weather information from that city and the current temperature. Actually, we publish on the topic weather-city, and we publish the current temperature. And then we wait for an acknowledgement of our publication. And so if you recall above, we've got that callback that says, that gets fired when the broker says, "Yay, verily, I've received your publication." So what we're doing is we're waiting for that before we continue. So we want to make sure that everything is flowing in the way we want it to. So we're maintaining the right state there. And that's it. It's basically the same as before, except that we have a little more complicated looping structure here for publication, and we're calling a new function current weather in order to get more interesting information than just, hey, how you doing? And so let's go look over at the client and see what changes were made there. Let's save this, go to the client. And the only change we made was the topic. And we said, tell me about this topic, and the topic I'm interested in now is anything to do with weather. So weather hashtag. And that will listen for anything under the topic of weather. So any city will be gathered by this particular client. And other than that, this is all exactly the same as before. And so let's go ahead and run these two together and see what we get. So here is the subscriber, and he is now listening. And here is the publisher, who is now going to go out and grab weather data, grab the temperature, and hand it back. And as you see, after each acknowledgement from the broker, we receive a new message over here. Weather in San Jose is 82 degrees, weather in Tucson is 94 degrees, weather in Phoenix is $107, woohoo, and weather in Atlanta is 89. So I guess I'm glad I'm living where I'm living right now. But that is this, so now we've moved on to the next phase. That, I think, is probably enough for this video. We have kind of introduced MQTT, talked a little bit about its structure and a tiny bit about its history. We have discussed the Eclipse projects and the Oasis projects that are in support of MQTT, and built a little Ruby application, distributed application that actually goes off, gets interesting information from the web, publishes it to a broker, and then has a client go and grab that information for its own purposes. So that is the kind of end-to-end picture of it. And next time we'll dive into switching brokers and moving over to AWS IoT Core and taking advantage of everything that it offers. So thank you very much. I hope you enjoyed the video, and see you next time.